Hey there folks, welcome to Module 7 of the CompTIA A course. This module is called Virtualization and Cloud Concepts. So I think by the name you can already get a pretty good idea that this is going to be all about virtualization and cloud. Pretty neato, right? So what are the main sections, you might ask? Well, there's only two in this module, guys. Two very interesting ones, I might add. The very first section we're going to be nosediving into is client-side virtualization. If you're wondering why it says client-side in the front of that title there, it's because this is something we're going to be doing on the client operating systems. So that would be something like Windows 10 or Windows 11. Generally, virtualization is something you would normally do on the server side, and we're going to be tackling this problem from the client's perspective. Doesn't mean we're not going to explain the server side of things. The second main section we're going to be nosediving into will be cloud concepts. So basically, what is the cloud? The various kinds of clouds we get. Yep, you get different kinds of clouds. What are the benefits? What are the drawbacks? Where do you use them? That kinds of stuff. Well, guys, if you haven't done it already, like usual at this point in the video, this is where I'm normally going to go and beg you to go and like the video. No, I'm just kidding. I'm not going to beg. But I would appreciate it if you guys go and smash that like button. And of course, if you'd like to know when the next module of this course comes out, remember to subscribe. Okay, let's jump into that first section, being the virtualization side of the coin. So the first section here is called client-side virtualization, folks. The very first topic we're going to be covering in this section is hypervisors. For those of you brand new to virtualization or hypervisors or virtual machines for that matter, hypervisors is the software we use to create and run what is known as virtual machines. These are commonly known as VMs for short, but the full name is virtual machines. If you don't know what a virtual machine is, it's exactly like a real computer. It just doesn't have its own resources. You can go and install an operating system of your choice on that machine. You can go and choose how much RAM it has, how much hard drive space it's got. All of the usual stuff you'll do in a normal computer. It's just, well, virtual. And since it doesn't actually have its own resources, where is it getting it from? It's getting it from the host on which it's running. So if you have a laptop or a desktop with some sort of hypervisor software, once you've got that software open, you would be able to create what is known as a virtual machine. Once you're going through the little wizard, you're going to be able to choose a name for it. Not that it really matters. You're going to be able to choose what operating system you want to install, how much RAM you want to allocate, how much hard drive space you want to allocate, and all of this resources that you're allocating to the virtual machine. You need to keep in mind it needs to come in from somewhere. It's coming from the host. The host is the actual machine on which everything is running. So the actual physical laptop, desktop, or server which you're running all of this on, that is the host, guys. And when you make a virtual machine, that is called a guest, because it's basically taking stuff from the host. Alright, so hypervisors wise, before we actually go and list a couple of things here, I know it's still blank on the screen for you guys. You get many kinds of hypervisors in case you guys don't know. I think one of the most common ones is probably Microsoft's Hyper-V. Microsoft literally took the name hypervisor and just shortened it to Hyper-V, and they call it their hypervisor. So they're not exactly creative with the naming. Hyper-V is normally something you would only find on the server side by adding it as a role. On the client side, however, Microsoft does say that this is actually available now. They say it's available since Windows 10, but if you go and check, you will actually find it on Windows 8.1. There's T's and C's to that, of course. So assuming you're running 8.1, Windows 10, or Windows 11, you need to run the right edition. So this is normally going to only be available on something like Enterprise or Professional Edition. You need to go and turn it on as a feature. So you're going to have to go to Add and Remove Programs, and there you'll be able to find Add and Remove Features. If you go in there, you'll find that Hyper-V is actually in that list, and it's just turned off. You just need to go and turn it on. A word to the wise, if you're about to go and turn that on, I would recommend you close everything on the machine and save all your documents. As soon as you try and turn that on, at first it's going to look like not much is happening, like it's about to install something. And after about a minute or so, suddenly the machine's going to restart and it's going to look like an update's basically taking place. What I don't like about that is it doesn't really give you the opportunity to save any documents or close anything. So if you had anything open, the chances are you might have lost your documents without saving it. It's not a nice predicament. So besides the Microsoft hypervisor called Hyper-V, There's other ones called VMware. You get Oracle, you get VirtualBox, Virtual PC. There's many hypervisors out there. At the end of the day, it's going to come down to your personal preference and you or your company's unique needs and requirements. The two main ones I've seen out in the field at most of my clients, and I've had hundreds of clients, is normally VMware and Microsoft's Hyper-V. I can't say that's going to be the same for you when you go out to your clients, but from my experience, those are the two main ones that I have seen. All right, so regarding these hypervisors, let's talk about resource allocation. We did actually touch on that indirectly, accidentally. When you're about to go and create a virtual machine, which I am going to show you guys how to go and do in Hyper-V, mind you, in case you're curious, you're going to have to go and allocate resources, like the RAM we spoke of, hard drive space, that kinds of stuff. So you need to be very sure of what the host has available before you actually go and allocate all of this to the virtual machine. You're going to have to ask yourself a lot of questions, all of which we'll go through in good time. Hypervisors does something called emulation. So it's all virtual. So you can still go and choose the operating system. And on that operating system, you can go and install softwares just like any other normal machine. But it's all emulation. The operating system that you install on that virtual machine can be anything. So if you're running this on a host machine and the host machine is running some sort of Microsoft Windows operating system, that does not mean that you are now obligated to go and install some sort of Windows operating system on the virtual machine. Most of us will, but you don't have to. You can go and install Linux, Unix, you can go and install Android, iOS, you can go and install anything your heart desires, guys. Really, you can. So I think now you guys have got a bit of a background as to what hypervisors actually are. These are the softwares you would go and install or turn on to run the actual virtual machines and to create the actual virtual machines. All right, so let's talk about uses for virtualization. Why would you want to go and do this? So this, in my opinion, depends on what kind of virtualization we're talking about, because we could be talking about virtual machines, which is what we're talking about here. It could be something called containers, something I have not explained to you guys yet. And it can be many other kinds of virtualization. So my honest opinion, it actually depends on what CompTIA means when they say virtualization. But in this case, I think it's safe to assume we're just talking about good old-fashioned virtual machines. So let's talk about client-side virtualization. Like in the beginning, we know this is something we're going to be doing on Windows 8.1, Windows 10, or Windows 11. And depending on what you want when you're watching this course, heck, for all we know, there might be a Windows 12 at that point in time. So when you go and create something like a virtual machine, this is kind of like a sandbox environment. It's a nice environment. It's a safe place for you to go and install stuff and test stuff safely for the most part. So let me give you guys a scenario. Maybe there's a program or a game that you're about to go and install on your real computer on the host, but you're not exactly sure how it's going to behave. Maybe there's malware in it because you got it from a friend. Maybe you downloaded it from some sort of unsavory, sketchy website. Maybe you're just downright scared that it's going to mess up your computer in some sort of way. So to avoid that from happening, if you're a paranoid fella, paranoid like my wife, you can go and create yourself a virtual machine, install an operating system, which I would recommend being the same as your host if you want to go and do testing, and install that program, game, or whatever it is on that virtual machine. Then you go and check what happens on the virtual machine. If it misbehaves, then you know you dodged the bullet. If it does not, and everything seems a-okay, then, well, proceed to install it on the real machine, guys. Virtual machines is a great way for you to install legacy applications and operating systems. So if you don't remember what the word legacy means, it means something is old. It could be an old program, an old game, an old piece of hardware. It is something that's 10 to 1 no longer supported. The vendor doesn't release patches for it anymore, or updates for it anymore, or parts for it anymore. Whatever it might be, it is something that's old and outdated. So if we're talking about old legacy applications, these are probably applications that no longer support it. If we're talking about old legacy operating systems, these are also probably operating systems no longer supported. So if I want to go and run those or test those, where would be a good place to do that? That, guys, would be a virtual machine once again. Now, client-side virtualization is also pretty good for testing software across different platforms. So maybe on your host, you've got Windows 10 or 11 installed, and you've got some sort of software you would like to go and test on other operating systems. These could be Windows, they could be non-Windows operating systems. Whatever the case might be, If you would like to install software and test software on other platforms, this is a great way of tackling that problem, guys. Install various operating systems on various virtual machines, and then you go ahead and install the software on those virtual machines, and then you get to go and test and see if it actually works. And then the last one I want to add on this topic of uses for virtualization is training. If you want to train someone, this could even be yourself, mind you, but it's probably going to be a couple of friends, users, staff, students, whatever the case might be. Training is a very good reason to go and use virtualization. So if I am going to go and teach a couple of students, and you guys are technically students of mine now if you're watching my courses, a great way for me to show you how to do something would be to do that on a virtual machine instead of doing it on a real machine, because it's possibly going to break the machine or it's going to make the machine behave in some sort of undesired way. I would much rather do this on a virtual machine, because the virtual machine I can always just go delete and recreate all over again. Alright, so we've spoken about client-side virtualization, so we know that is on the user side usually, so that would probably be on your laptop, your desktop. Your 10 to 1 going to be running Windows 8.1, Windows 10 or 11 on there. So let's talk about server-side virtualization. Based on what I said in the beginning of this video, I think some of you guys might have an idea what that is. It's pretty much the same thing, it's just going to be running on a server. So if we look at something like Hyper-V on the client side, you would need to go and turn that on as a feature. If you look at the server side, you would need to go and add it as a role. Now, when it comes to the other virtualization softwares I've mentioned, like VMware and so on and so forth, those would still have to once again be installed on the server side, and you can then go and run them and manage them obviously from the server side. So one of the benefits or uses for server-side virtualization is better hardware utilization and flexibility. Because it's not running on your machine now, it's running on a server. And let's face it, servers normally have a lot of resources, guys. They're made for this. Where client operating systems might not necessarily be made for that. Another useful virtualization, guys, is application virtualization. Yep. So instead of running some sort of virtualization software on the server side or the client side, which allows you to run a full-blown virtual machine, now we're talking about something entirely different to virtual machines. It's still virtualization, don't get me wrong, but it's specifically just the application. So you get things like AppV, just to give you an idea. AppV is short for Application Virtualization. That allows you to stream an application to the client side, and on the server side, you can kind of more or less choose what applications these users are allowed to install and what not. Now, on its own, that doesn't really sound like a benefit, but one of the benefits to normal application virtualization is every application that gets installed on a user's computer then is in its own isolated hypervisor environment. It's in its own little sandbox environment. So if you need to have more than one program installed on a user's machine, and normally this would give you an error if you try and install the same program twice. So maybe I want to install Office 2007, and at the same time I would like to install Office 2010. Normally that would not work. Believe it or not, it's actually going to give you an error, and that's simply because the registry is going to see it as installed already, even though it's technically a different version. And now it's in an isolated hypervisor environment. It's like in a little bubble. It's still sharing. It's got its own little registry and its own little everything. The operating system cannot see the program cannot see the operating system, which means you can actually install as many as you like. At the end of the day, you're only going to be limited by the amount of RAM available on the host and the amount of space on the hard drive. So that's the only real limitation, guys. Under the topic of application virtualization, guys, you also get something called remote app, which is not actually included in this course. AppV and remote app is not actually mentioned. I'm mentioning those for you guys as an extra, so you know what the heck we're actually talking about. A remote app is when the application that we're talking about is actually installed on the server side, not the client side. So whatever this application you want to run on your machine or the client's machines, you're going to be installing it on the server. It's going to run on the server. It's going to occupy space on the server, and you will just be streaming this application to the users and their devices. As long as the user's got a screen, and as long as they pretty much have something like an internet connection, they can run that application. So maybe their laptop or tablet or whatever it is we're talking about has only 512 megabytes of RAM or 1 gig, and the application that we're talking about requires 2 gigs. Now, how the heck are you going to run that on those those tablets and laptops? Well, if you go and install it on the server and you run it as a remote app, then it doesn't matter how much resources these devices have, because the application is all running on the other side. It's all installed on the other side. It's just displaying on the user's device via an internet connection. So that's an amazing way to get applications to run on people's devices without them necessarily meeting the minimum requirements of those applications. All right, folks, and then the last one I want to mention here as a use for virtualization, and keep in mind, once again, these are not the only uses for virtualization. These four that I'm mentioning for you guys are simply the ones that's included in the course. So that would be container virtualization. For those of you not familiar with the term container, this is something very similar to a virtual machine at first glance. So a virtual machine has its own operating system. It looks exactly like a real computer. It behaves like a real computer. It even has its own operating system. It just does not have its own hardware. Containers, on the other hand, looks just like a real computer as well. It's pretty much the same thing as a virtual machine at first glance. And when you connect to a container or a virtual machine over the network, you or the user connecting to that container or virtual machine would never know it's a container or virtual machine. So the only real difference here between containers and virtual machines is containers, you manage them differently, you create them differently, and containers don't actually have their own operating system. That comes with its own benefits and it comes with its own drawbacks, like you would expect. So if a container does not have its own operating system, where does it get it from? It gets it from the host on which it's running. So whatever the host is running, so if your host is running Server 2019 from Windows, the container will be running Server 2019. Now, it doesn't really matter what's on the host. You can have lots of softwares and programs and lots of stuff on your host. You can have lots of documents and files on the host. But if you go into that container, it's going to seem like a brand new blank computer, as if you've just installed Windows. So whatever is in the host is not going to be accessible on the containers. There's no data leakage. You don't have to be concerned about that. Any programs installed in the host, any documents lying on the host, none of that is available on the container. It truly, bluely is just like a new computer, and any software you would like to use in that container, you would have to install it first. Any documents you would like to access in that container, you're going to have to drop it on that container first. But at the end of the day, it's still sharing the actual operating system kernel files and all that. So that's the only real thing that it's sharing here. Comes with benefits, comes with drawbacks. Drawback is you cannot choose the operating system. A benefit is the operating system is not occupying additional space. So if I've got 10 containers, that's not 10 operating systems installed now. It's still just one operating system, guys, because all the containers share their operating system with the host. If you need to deploy or start up a container, it's nearly instantaneously, because if you think about it, the operating system was technically already running. If you look at the benefits and drawbacks of a virtual machine, one of the obvious benefits is you can obviously choose the operating system. So you've got control over that. That's a nice benefit, and that's normally a deal breaker for a lot of people. A drawback is if you want to start one of those virtual machines up or deploy them, it is going to take as long as a normal computer because you are effectively starting up an operating system from scratch. From cold, if you want to call it that. So yeah, regarding container virtualization, let me just add this here. Run apps within an isolated workspace. That's what CompTIA says. It is an isolated workspace, but fact of the matter is a virtual machine is actually the same thing. All right, let's move on to the next topic, boys and girls. Virtualization resource requirements. So if you would like to go and run virtual machines, let's keep it very simple here. You've decided you want to run a virtual machine on your laptop, your desktop, or your server. There's a couple of things you need to go and look at first before you can go and do that. So one of the first things you need to go and look at is CPU platform. So your CPU has to support virtualization. That's tip number one. Good news here, guys, is almost all CPU support this nowadays. If you go back about 10 years in time, not all CPUs had to support that. You actually had to go make sure the CPU supported that. And if it did support it, it did not necessarily work by default. You would have to actually go and turn it on in the BIOS back then. Nowadays, we don't even have a BIOS. We just have a UEFI. So make sure the CPU supports virtualization. You also had to make sure back in the day that the CPUs supported 64-bit operating systems. Virtual machines is something you can only run on a 64-bit operating system. Does not run or work on a 32-bit operating system. Why, you might ask? Well, 32-bit operating systems or architectures have got a lot of restrictions to them. one of which is RAM. If you're going to go and install a 32-bit version of Windows as an argument, you're going to find it's going to limit you to about approximately it's actually about 3.3 gigs of RAM. So physically, you might have 8 gigs of RAM installed, but if you go and check how much is available or usable, as Microsoft says, you'll find it's actually only about 3.3 gigs. And that's not enough because your Windows on the host operating system is going to need at least about 2 gigs, if not more, which means there's no RAM left for the virtual machines, guys. It's not going to work. So that's one of the obvious restrictions here when it comes to the architecture and the bits. So you need to make sure CPU supports virtualization, you need to make sure the CPU supports 64-bit, and you need to make sure that you actually go and install a 64-bit operating system, and you also need to make sure that operating system actually comes with Hyper-V or whatever included, and that it's supported and all that kinds of nonsense. Other requirements you might need to look at is the RAM. This machine where you plan on running virtual machines needs to be beefed up in more than one way. It needs to have a lot of RAM. How much, you might ask? I don't know. It depends on how many virtual machines you plan on running, and it depends on how many of them is going to be running in one go, and lastly, it might depend on what you plan on actually doing on those virtual machines. So you need to go and ask yourself, what operating system are you running on a host? What is the minimum amount of RAM you need for the host? What operating systems are you going to be running on the virtual machines? What is the minimum amount of RAM needed for those virtual machines? And so on and so forth. I'll go through all of this with you guys in just a moment. There's going to be a bit of a demo where I'm actually going to open Hyper-V for you guys. And I'll show you guys how to make a virtual machine and all the questions you need to go and ask yourself. So stay tuned for that demo. If you can't wait for the demo, then just check in the video description down below for the timestamps where I go and write Hyper-V demo or virtual machine demo. Something like that. Then you can skip ahead to that section. Alright, something else you guys need to be concerned about with regards to requirements is mass storage space. That's how CompTIA phrases it, but in reality we're just talking about the hard drive here, guys. Don't get confused by the fancy technical words. It is just the hard drive. So these virtual machines that we're about to go and create, where do you think they get installed and created? It gets installed and created on the host, guys. So you need to make sure that host of yours has got a lot of free space. Otherwise, where are you going to put all of this? Lastly, guys, networking. These virtual machines are effectively real computers. They're just virtual, but they are real nonetheless. So if they need to connect to one another, if they need to connect to virtual machines on other hosts or other hosts in general, or if they need to connect to the internet, how the freaking heck do they do that? Well, they are going to have to share the resources of the actual host once more. In this case, we're talking about the network card, guys. Alright, so I think we've talked enough nonsense about the requirements with regards to virtual machines. So I think let us give you guys a bit of a quick demo with regards to Hyper-V. So I've got Hyper-V running in the background. I'm going to switch over to it now. So switching over.
A few moments later.
Alrighty folks, here we are on Hyper-V. So if you're wondering, I'm running Windows 10, not that it matters. You can be doing this on Windows 8.1, Windows 10, and Windows 11. Either way, potato, it's the exact same thing. You're still going to have to go to your and remove programs. You're still going to have to go and turn Hyper-V on as a feature. Once you've done that, this is more or less what you would see. Now at first, you might see a blank screen. It might look actually something like that. That's what it might actually look like. What you need to do is to go to the left here, click on the machine's name, and then you will see this window. Now, the moment I have two virtual computers here already, one has got Windows 10 installed, the other has got Windows Server 2019 installed. What you're going to see in the beginning is probably going to be blank. You're probably going to have nothing here when you come in here for the first time. And it's going to be up to you what virtual machines you create, how many you create, what you install on them, obviously keeping in mind your resources. So let's go and ask ourselves those questions I've been talking about. How do we create a virtual machine? So in Hyper-V, at the top right, there's a button that says New. And if you go look at the other virtualization platforms, VMware, Oracle, VirtualBox, all of those other ones, they also have some very clearly labeled New button. You're generally going to be going through some sort of wizard, which we're going to do in just a moment. In that wizard, it's going to ask you more or less the same questions, just of course in a different order. It's going to ask you the name of the virtual machine that you want to go and create, how much RAM you want to allocate, how much hard drive space, all of that kinds of nonsense. So let me go ahead and click on New here at the top right. There we go. New virtual machine is what I want to go ahead and create myself. There we go. And where is the wizard, guys? I'm going to zoom in a little bit here for you guys so you can see a little bit more clearly what the heck is going on. Otherwise, if anyone's got a small screen, you're going to struggle to read the text here. So I'm going to zoom in. By now, we should be zoomed in. Next. All right. So let's give this virtual machine a name. So I need to go and ask myself a question. What do I plan on using this virtual machine for? So, and you also need to go and keep in mind, are you going to be running multiple virtual machines on this host, or is it just going to be like one or two? If this is going to be on something like a server, which is very often going to be the case, guys, the chances are you might very well have many virtual machines. I've had clients that had hundreds of virtual machines. And if that is the case, it's very important for you or the other technicians to label these things properly. If you don't label these things properly, and you come back here tomorrow or next month or 6 months later, you're going to have no idea which virtual machine is which virtual machine and what is what. So if I am your boss and I ask you to quickly go and configure something or do something on a specific virtual machine, and you go there and you see there's a couple of hundred virtual machines, how are you going to know which one is which? You're not. So as a courtesy to yourself and as a courtesy to your fellow man, give this stuff a proper user-friendly name. And on that note, before you go ahead and just give it a nice name, I would also go and double check with your company if there's not a specific naming convention you've got to follow. Yep. So for now, I'm going to keep this simple. I'm just going to call this Win10 for Windows 10. I could probably just call it test because it's just a demo. I'm going to click here on next. Do you want to use Generation 1 or Generation 2? This is something that's applicable to Hyper-V. This is not applicable to the other brands of virtual machines. In the beginning, Hyper-V only had Generation 1. So this would not be a menu. It would have skipped straight to the next menu, which you can see here is about assigning memory if you check here on the left-hand side. But at the moment, we've got Generation 1 and Generation 2 to pick from. Generation 1 gives you access to old legacy functions and features. Remember, the word legacy means old stuff. So if you were to go and use Generation 1, which actually is what most companies are still using at this point in time, it gives you the ability to go and install a 32-bit operating system. I don't know why you'd want to go and do that. It gives you a BIOS. It gives you the ability to go and use IDE or PaaS devices. It gives you the ability to go and install an operating system on the virtual machine using the actual physical optical drive of your laptop, desktop, or server. It gives you the ability to go and use a floppy disk drive. God knows why you would want to go and use that, but it does give you that ability. So that's just to give you a taste of what Generation 1 includes and what old functions and features you might still have access to. If you were to go and choose Generation 2, some of these are going to fall away. For instance, you will no longer have the ability to go and install an operating system onto a virtual machine using the actual physical optical drive. You're going to have to go and use something like an OSI disk of some kind. Generation 2 does not have floppy disks. Generation 2 only supports 64-bit. And Generation 2 has a UEFI-based firmware, not the BIOS. If you are about to go and create a virtual machine, if it's your very first virtual machine, I'm going to recommend going for Generation 2. Newer is usually better. But if you're about to create a virtual machine, and your company or your client currently has existing virtual machines in their environment, you need to be careful, guys. Generation 1 and Generation 2 don't play well together from what I've seen. So if they currently have Generation 1 for those virtual machines, if they're all Generation 1, which is 9 out of 10 times going to be the case, I would suggest making the new one also Generation 1 from a compatibility standpoint. You don't have to take my word for it. I mean, if you want to go and use Generation 2, be my guest. But do not come complaining to me if you run into compatibility issues. So for now, I'm going to keep it to Generation 1 because let's face it, that is what most of you guys are going to be using. I'm going to click on Next. Here, we're about to go and assign RAM, system memory, to the virtual machine. So I'm going to have to ask myself a lot of questions here before I can do that. And the same is going to happen under some of the other hardware resources. So the very first question that you're going to have to ask yourself here is, what are you about to install on this virtual machine? In other words, what operating system? Let's keep it simple. Windows 10. Remember, the title was Windows 10 of this virtual machine. So now I know I'm going to install Windows 10. Now I need to ask myself, what is the minimum RAM requirements to be able to run Windows 10? The majority of manuals will tell you it's 1 gig. Yeah, you might be able to start Windows 10 if you're lucky, very lucky, but that's it. You'll probably just land on a desktop, and if you do anything, it's going to crash. So in reality, the minimum requirements for Windows 10 realistically is at least 2 gigs. 1 gig is 1024 megabytes. So 2 gigs, guys, would be how much? 2048. Now, before we go and click on next, no, guys, we're not done yet. There's still a couple of questions we need to ask ourselves. Unfortunately, that is how this stuff works, guys. I know it's tedious. So now we know I've met the minimum RAM requirements. Before I click on next, I need to ask myself, what do I plan on actually using this virtual machine for? Depending on what I plan on using it for, you might find a 2 gig is not going to cut it. You might find that, oops, I need 4 gig, or oops, I need 8 gigs. Depending on what you plan on installing, depending on what you plan on running on this virtual machine. So for the purpose of this demonstration, let's say I've come to the conclusion that I need 4 gigs of RAM because of what I'm going to be using it for. There's a button here you can go and use if you want to. It used to be unticked by default. Now I see it's ticked by default, which is actually a good thing. So if you leave it ticked by default, which is what I recommend, that means you will give this virtual machine 4 gigs of RAM, but it will not necessarily use 4 gigs of RAM. That's just the limit you are specifying. So if this machine is just idling there one day, you would find that very often when a machine idles, it actually just needs about 500 megabytes, maybe to 700 megabytes of RAM, which means you're wasting about 3.5 gigs of RAM approximately. Just waste it. So now if you go and choose that dynamic memory tick box, which is the default option, any RAM that is not being used goes back to the host, which means the host can use it for itself now, or it can be used otherwise by, for example, other virtual machines perhaps. If you were to go and untick that box, which is being, I would say don't do that, you need to be very careful of that. That means the machine will get 4 gig, but it's not a limit. It's more like it's going to get that, and that's the end of the story. Whether it needs it or not, it will get 4 gigs from the host. So as soon as you start the virtual machine, it takes that from the host, and the host will only get that back if you either go and turn the virtual machine off or, well, delete it. So for now, let's leave it on 4 gigs. Let's click on next. Here you need to go and choose a virtual network. So this virtual machine, it might be virtual, but at the end of the day, it can still connect to other virtual computers and other physical hosts and virtual machines on those other physical hosts. And lastly, the internet, guys. In the beginning, when you come in here for the very first time, it's going to say not connected, and you're going to find there's nothing in this list. The reason why I've got 3 things in this list is because I went and created this for some other course that I was doing. I can't even remember what course that was. You can give them any name you want, these networks. I've called them based on what kind of network they are. There's 3 kinds of networks you can go and create. And you get a private, internal, and external. So if I made a private one, I would actually call it private, so I know which one is which. If I made an internal one, I would just call it internal. So I know I wasn't exactly creative with my naming, but my naming is practical. Darn gosh, it is. So at least I know what it is. If I just called this banana network, I would have no idea. Is that an internal network or a private network? Especially if it's been 2 months. I'm not going to remember. So for now, I'm not going to choose that quite yet. I'm going to leave a bookmark here because I want to show you guys how to create this virtual network. It's called a virtual switch. So we'll show you guys how to create a virtual switch. So for now, let's leave a bookmark here. Next, here you are about to create a virtual hard drive or choose a virtual hard drive. So just like of the RAM, I'm going to have to ask myself a couple of questions. What am I about to install? You would remember that's Windows 10. What is the minimum hard drive requirements for Windows 10? If you go check in your manual, for a 32-bit Windows 10, it is 16 gigs. For a 64-bit Windows 10, it's 20 gigs. A whole 4 gig swing between the two architectures, I know. Now, what I've just given you guys is without any updates. There's no updates, no drivers, no nothing. That's bare minimum. So you're probably going to have to go and install updates. Let's face it, you are going to. So there's updates, drivers, programs. At the end of the day, you're going to probably end up around 40 gigs or 50 gigs of space that are being used. Then that's still without any documents and files. So realistically, you're probably going to need at least 50 gigs to 100 gigs for a virtual machine, if not more. So if you're about to create a virtual hard drive, let's say I've come to the conclusion that I need 50 gigs or 60 gigs. Let's leave it on 60. I need 60 gigs. That's what I decided on. Do I actually have 60 gigs to give to this machine? I might not. So you need at least 60 gigs of free space on a hard drive, if not more. And you have to go and ask yourself the same question here of RAM, guys. If you're about to assign RAM, if I've come to the conclusion that I need to give this machine 4 gigs of RAM, Do you have 4 gigs of RAM to give? I'm on a laptop today. I'm doing this video on a laptop. This laptop has got 16 gigs of RAM. So I need to go and ask myself, what operating system is the host? My host is Windows 10. The host needs a minimum of 2 gigs of RAM. So that's 16 minus 2 gigs. That means I've got 14 gigs left, or maybe even less, depending on how much the host needs. And if you minus that now, that means I've got about 10 gigs left. But is it really 10 gigs? Because maybe there's other virtual machines. And if you check here in the background, let me zoom out here. There's actually other virtual machines. There's 2 of them. So what other virtual machines are running here? How much RAM have been assigned to them? Will these virtual machines be running at the same time? And will the host still have enough RAM if I'm going to be making this new virtual machine? You might find that the host has enough RAM for this virtual machine now, but as soon as I start these other virtual machines in the background up, it might no longer have enough RAM. The same goes for the hard drive here. So let me zoom back in here on the hard drive. Same can of worms, guys. So yeah, let me click on next. Oh yeah, here you can actually go and choose an existing hard drive. So just like a real computer, where you can go and take a physical hard drive out of one laptop or desktop and transplant it, basically like an organ, into another computer, you can actually do the same thing with virtual computers, believe it or not. And with a real computer, that hard drive you're transplanting, it could have an actual operating system installed. You might just need to go and install the drivers again, to get it to work properly. If it's a secondary hard drive, you just plug and play. The exact same can of worms here with virtual hard drives, guys. And I can lastly go and say, you know what, I just want to attach a virtual hard drive later. So for now, I'm just going to say attach later. Click on finish. It takes only a couple of moments. And there we go. You can see there's my new virtual machine there. Now, as for the virtual networks that I was talking about, I told you guys bookmarked. We're going to get back to that. And this is me getting back to it. So here on the right-hand side, let me just make sure I'm zoomed out enough. It says Virtual Switch Manager. If I click there. If you come in here for the very first time, you'll only see this section here that's highlighted in blue. And you might see this section here, which is highlighted in blue. You're not going to see that, or that. I've made those afterwards for other courses, for other people. So if you want to make a new virtual switch, you're going to go here where it says new virtual switch. I mean, duh, it says it there. And then you need to go and choose which kind of network you want to go and create. Something to keep in mind is you can actually go and change this at any point in time. So if you go look at these 3 other ones that I've clicked on, that I've created, I can go to any one. Let's click on this one at the bottom. And you'll see I can, at any point in time, I can actually go and change this again. So let me just use this one. If you go and click on private, or if you choose to go and create a private virtual switch, virtual machines here in the background can only communicate with one another if they are on the same virtual switch. So assuming they're on the same virtual switch, they can only communicate with one another. That is it. They cannot communicate with the host on which they're being hosted. And they can most certainly not communicate with anything beyond the host. In other words, anything external. Now going back to that virtual switch list. If you look at this one here, the other one, it says internal. If you were to go and choose internal, those virtual machines in the background can still communicate with one another like before, like a private switch, except now they can also communicate with the host. So there's a little bit of leeway here. They've given you a bit of slack. So private can only communicate with one another. With an internal switch, assuming they're on the same switch, they can communicate with one another as well as the host. But of both of these switches, traffic does not have the ability yet to leave the host and go beyond the host. I think you guys can kind of guess what this one is going to be about. The one here, it says external. External has no restriction. The virtual machines can communicate with one another. They can communicate with the host. They can communicate with other hosts, virtual machines on those other hosts, and obviously the internet. There is no restriction. Now, since traffic has the ability to leave the host, you need an actual network card. Do virtual machines have a network card? No, they do not. Where are they going to get it from? The host. So you need to share it with the host. You will find there's a drop-down list if you go and choose external. In this drop-down list, you're normally only going to see one, which is going to be your RJ45 port. That's your normal LAN cable port. Unless you're using a laptop like me today. So that one there is my normal RJ45 port, my LAN cable port on my laptop. And that is my wireless. Both of these are network cards. So before I go and choose one of these two, I need to go and check what am I connected on. If I'm connected on a cable, you can see that at the bottom right next to your system clock normally. If you're connected via cable, you might want to choose that one. Otherwise, if I choose wireless, but I've got a cable plugged in, yes, theoretically the virtual machines will have access to the outside world like the internet, but unless you go and plug yourself into a LAN cable, it's not going to work. So you need to make sure you choose the right one. Go and check what you are connected on. If you're connected on wireless, make sure you choose wireless here. If you're connected on a cable, make sure you choose cable. Otherwise, the virtual machines will theoretically have access, but they won't actually have access until you actually go and connect to one of those networks. I've got a third one here, which I used for some other course as well. A tip I want to also give you guys here, which has got nothing to do with the course, it's just a tip in real life. If you ever find yourself needing to create an external switch, delete an external switch, or switch to or from an external switch, never, ever do that in working hours. Because when you do that, it drops the internet on the host for a couple of seconds, sometimes up to a minute. It might not seem like a big deal to you, but if you're doing this on a server that's got a couple of, let's say, 100 virtual machines running, and a lot of these are actual servers on those virtual machines, and these are, in the production environment, all that, you could very well cause a disaster in that company. This could be a matter of this company has suffered millions in damage. You do not want to be that guy. So I highly, highly, highly recommend you make this, delete this, or change to or from this only after hours. Never within working hours. Internal and private, you know what, you can go and do this whenever. They're not going to have any influence. It's that one you need to be very careful with, guys. Alright, and then one last thing I want to show you guys before we move on to our next topic. Let me just cancel this. When you've got your virtual machine created and you want to go and switch to those virtual switches that we've just made now or showed you guys how to go and make, you can go right click on the virtual machine in question like so. And you can see I can obviously start if it's not started. There's an option that says settings. If you were to go and click on settings, this is kind of the same as opening a laptop or a desktop. Let's say it's a desktop PC. So if you open a desktop PC and you remove the side panel and you're picking inside, what do you think you're going to see? You're going to see the motherboard, the CPU, the RAM, the power supply, the hard drives, that kinds of stuff. And if you click on settings here, it's effectively the same thing, just digitally speaking. So let me click on that. There we go. It might not look like much, it might look a bit confusing, but it's actually pretty simple, and this is like looking at the inside of your box, guys. For example, there is my memory. I can go and increase the RAM or decrease the RAM. If I increase the RAM, you can imagine yourself adding RAM chips on the motherboard. If I decrease it, you can imagine yourself removing RAM chips on the motherboard. Pretty straightforward, is it not? Now, here you'll see it says network adapter. I can actually go and add more than one network adapter, just like a real computer. We'll keep it to one for now. And it still says not connected, just like when we made this virtual machine. And if I go there, I can actually go and choose one of these virtual networks. That's kind of like plugging a LAN cable out of your machine and plugging another one in, or disconnecting from one Wi-Fi and connecting to another Wi-Fi or hotspot connection. So if I am on one and I just switch to another one, you can imagine yourself just plugging a cable out and just plugging another one in from another network. Pretty straightforward, isn't it? If you go here to add hardware, obviously that's where you can go and add more hardware like new network adapters. Pretty straightforward. Do you need to go and add extra hard drives or extra CD-ROMs? You just go here to IDE. Remember, we're working off Generation 1. So Generation 1 still has access to IDE and PaaS. This is not something you'll have access to in Generation 2, but it's still the same principle. So I can go and choose, do I want to add a hard drive or a DVD-ROM to those controllers there, of course. Well, guys, that is a bit about Hyper-V. I've shown you guys how to create a virtual machine. I've shown you some of the questions, or if we discussed some of the questions you need to go and ask yourself and all that kinds of jazz. So let's move on to the next topic. Alright, so here's the next topic, and this is actually the last topic in this section. Virtualization security requirements. Ooh, fancy, is it not? First up, guest operating system security. So if you guys haven't heard me say it earlier, because maybe you use the timestamps in the video description, the guest is the virtual machine. The host is the actual physical machine on which the virtual machines are running. What do we call the operating system running on the host? It's called the host operating system. What do we call the operating system running on a virtual machine? It's called the guest operating system. So when I say something like guest operating system security, now you know what I'm talking about. I'm talking specifically about security on the operating system on the virtual machine. So just like a real computer, because these virtual machines, they might be virtual, but they're exactly like a real computer, it's still just as important to do your patches, to do your updates, and to make sure you've got an antivirus on there, to make sure you've got a firewall on there, to make sure they're turned on and make sure they're updated. So it's exactly like a real computer in that sense. It might be virtual, but everything else still applies, folks. Now, what about the host security? Remember, host is the actual physical device on which all of this is running. There's a bit of a downside here. Increased risk from hardware failures. What is meant by that, you might ask? Well, remember, you might be running multiple machines on your host now. So if I've got 20 virtual machines running on my host, if I have some sort of hardware failure, let's say the hard drive crashes, or a RAM chip fails, or the power supply fails, is it really just one computer that just failed? No, it's 21. It's the host, which is 1, plus the 20 virtual machines. So you have 21 computers or servers or whatever that has just gone down, not just one. So the risk associated to all of this is a lot higher. And in the companies where we can actually afford it, we try and do what we call redundancy and high availability. So the servers that actually host these virtual machines will do our best to have multiple servers. So these virtual machines will be split across 2 or 3 servers which are identical in all ways. And if God forbid something happens to one of these hosts, then everything is not offline because you've got backup servers hosting the same virtual machines. And that means the virtual machines, whatever services they're rendering, these services at no point in time will become unavailable. So that gives you high availability. So very difficult to implement this sometimes because of the price factor. It's pretty damn expensive, folks. Let's talk about hypervisor security. Remember, hypervisor is the actual software we use to run these virtual machines. So when it comes to security in the software, manage your patches and security of hypervisor. It's very important for you to go manage the patches. So the patches we're talking about is the host operating system. Make sure your host operating system is up to date. Make sure it's patched. And make sure that your Hyper-V is up to date and patched with the latest versions and additions and all that kinds of nonsense. Lastly, folks, isolate host from guests and isolate guests from other guests. The guests are the virtual machine. The host is the actual physical machine which is hosting these virtual machines. So you want to do your best to isolate these from one another so that if one of them gets infected with something like malware, then at least it is controlled. It's only going to be limited to that one virtual machine or just the host. It's not going to go and spread to everything and everyone else. Something we want to do our best to obviously avoid. Alrighty, so that brings us to the end of the first section, and finally, folks, we can now jump into that second section, which is cloud concepts. Like I said in the beginning of the video, in case you guys haven't heard it, this is all about cloud, what cloud is, the different kinds of cloud we get, what do we use them for, and maybe a couple of examples. So I think let us start here at the beginning. Cloud characteristics. What is the cloud? So we are truly bluely starting at the beginning. This is for people that's brand spanking new to IT that truly have no idea what this is and that would like to go and write the exam. Then you really need to watch this. So what is the cloud? The cloud, guys, is the concept of putting something somewhere else on someone else's property. So if I've got something like data or a program on my laptop or my desktop, it really is just data. It really is just a program. If I've got that data or that program on my server, is that cloud? No, it's not. The data can be accessed via a network, but it's not cloud yet because the server belongs to me or my company. If you've got a program installed on your server, it's still not cloud, guys. Even if you access that program via the network and run it via the network. This can be a lot of other things. This could be remote desktop. It can be remote app. It can be app V. It can be many other things, but it's definitely not cloud. That might be virtualization, which we discussed earlier, but it's not cloud because the property still belongs to you or your company. So when it becomes cloud, is when it's on someone else's property. So as soon as I take that data of mine or that program that I want to install and I install it on some other server for some other company, or I access my data on some other server for some other company, that is cloud. It doesn't actually matter where that someone or that entity is. That entity with that server, which is now hosting or storing my data, or hosting or running and storing my program, that entity, believe it or not, could actually be across the street. They could be next door. They could be across the street. They can be in the same town. They can be maybe across the country or in a different country. It does not matter where they are. It does not really matter who they are as long as they are not you and your company. That is cloud. So if someone stores my data on their server and it's not my company, and they allow me to access my data on their server and they charge me a monthly fee for that, what do we call that, guys? It's a form of cloud. It's storage, but it's cloud. If I install my program on a server that doesn't belong to me, and they allow me to run that program over the internet from their server for a monthly fee, what do we call that, guys? It's called cloud. All right, so now we've got a fair understanding of what more or less the cloud is. You get different kinds of cloud, guys, and believe it or not, you get subcategories of cloud. I kid you not. All right, so first of all, you get something called private cloud. I don't really like this one because there's a lot of debate about this one, whether it actually is cloud. So if you or your company have your own data center hosting all your own stuff, that could be an example of private cloud. But not a lot of companies can afford that because it's really, really expensive. You can alternatively go and approach some sort of company in your general area that has their own data center, and you can go and rent space there. And that could also be a form of private cloud. Both of these situations is going to cost you an arm and a leg. So that's an obvious drawback about private cloud is the cost factor. A benefit to that is private cloud is probably the kind of cloud that's going to give you the most control because it's within your hands. It really is. You can do pretty much whatever. Then you get the kind of cloud we call hybrid cloud. That means some of the stuff we're talking about is going to be physically on premises in your office, and the other half of it is going to be online on someone else's service like Microsoft. So an example of this will probably be Active Directory. There's a lot of companies out there that's got Active Directory on premises, which we've been doing since the beginning of time. And at the same time, they've got Active Directory in the cloud now. And they've synchronized the Active Directory in the cloud with the Active Directory on premises, and that is called a hybrid Active Directory environment. More on that later. Then you get the kind of cloud called public cloud, which is probably the most popular option and the most widely used and most widely known kind of cloud. Public cloud means everything we're talking about is 100% on someone else's property somewhere else. That is what public cloud is. Doesn't matter whether we're talking about software, programs, whatever. This could even be a virtual machine. It doesn't matter, guys. Public cloud is 100% on someone else's property somewhere else. Now, within the category of public cloud, yes, I said public category. Yes, you heard right. I said category. There's three main kinds you need to be aware of. I want to make it clear that these three that I'm about to list for you guys are not the only ones. These three I'm about to list is simply the most well-known ones, most common ones, and most widely used ones. So let's start with the first one. Infrastructure as a service, more commonly known as IaaS for short. So you get infrastructure as a service, you get platform as a service, which is also commonly known as PaaS, platform as a service. And then the last one I'm going to list for you guys today is software as a service, commonly known as SaaS. So those are the short abbreviations there at the back for you guys in pink. So what are these things I'm talking about? I think let's look at the first one, infrastructure. What classifies as infrastructure now in this category? That would be something like a virtual machine. Those virtual machines I showed you guys earlier on Hyper-V, that is a very good example of infrastructure. It's not the only example. You get many other examples I can give you guys, but a virtual machine is probably one of the easiest and most common and most obvious examples I can give someone that's brand new to this. So those virtual machines I showed you guys on Hyper-V, where are they installed? On my laptop. So where are they taking space? On my laptop. Whose RAM are they using? My RAM. Whose CPU cycles are they utilizing? My CPU. But that's infrastructure. It's not cloud, it's just infrastructure. Now if I take that virtual machines I showed you guys and I upload them to a cloud platform, like one of Microsoft's platforms like Microsoft Azure, that would be infrastructure as a service. You can either go and upload it to the cloud, or you can go create it from scratch in the cloud. Potato, potato. The point is, When you've got a virtual machine in the cloud on some platform like Microsoft Azure, that, folks, is called infrastructure as a service. I think to help reinforce this, I actually have a browser in the background and I am logged on to a platform called Microsoft Azure. If you guys are not familiar with Microsoft Azure, it is one of Microsoft's biggest cloud platforms. Most certainly not their only one, but it's probably one of the biggest ones out there. The amount of things you can do on there is infinite at this point in time. One of them is infrastructure as a service, and that includes virtual machines. So let me switch over to the portal quickly.
A few moments later.
Well, folks, here we are on the Azure portal. So if this is your first time seeing Azure, ta-da! That's what it looks like. So as I've said, this is one of Microsoft's many cloud platforms, one of their biggest ones. And yes, the list of things you can do on here is mind-boggling. So I'm going to go to virtual machines as an example of infrastructure as a service. You can either click on it there, or I can go here to the left. This is called the navigation menu or the hub on Microsoft Azure. Not that you need to know that. And this is only going to give you a bit of a taste of what is accessible on Azure. It basically shows you some of the most common things someone would basically want to go and use on Azure. Some of these are infrastructure as a service, some of them are platform as a service, some of them are software as a service, and you get a couple of other ones as well, which is as a service. So I can give you guys multiple examples, but we're going to keep this as simple as possible. So if I go here to where it says virtual machines, like so, you'll see I can now go and create myself a new virtual machine. So this is an example of infrastructure as a service. If you go and compare the three we mentioned to you guys earlier, infrastructure, platform, and software as a service, the one where you've got the most control is infrastructure as a service. With all forms of cloud, you're always going to be relinquishing some level of control. But infrastructure as a service is the one where you still have the most amount of control. So yes, these virtual machines are not running on your service, they're running on someone else's service. So you can't physically see the service, you can't physically touch them, you can't physically go plug things in and out, but other than that, you actually still for the most part have control because you can still go and choose the operating system, folks. If I were to go click here on create, I don't know if it's actually even going to go through because I think my subscription has expired here, but let me try my luck and click on it. Let's ignore some of the stuff. You can see it says disabled because mine is expired. It was a trial. Let us see. So if you go here to the bottom, image, you can go and choose an operating system. So the fact that I can choose the operating system means I'm in control of that. And once you've installed an operating system, you can go and install whatever you want on an operating system. You can do whatever you want. So on the outside, where you go and specify the specs of the virtual machine, like the operating system, how much RAM it needs, and all that kind of stuff, even that you've got to a large extent still a lot of control over that. But once you actually log on to the virtual machine, once it's made, it's full access. So truly, bluely, you've got a lot of access still, guys, with infrastructure as a service. Now, if you look at the other one we had on that list, I'm not going to go back to the list, ziggity zag. The other one we had on our list there was platform as a service. So an example I can give you guys is if we go to this list here once more, there's quite a few, but I'm going to keep it as simple as possible for you guys. There we've got something called Azure Active Directory. Now, before we click on that, if you needed to have a normal Active Directory in a normal company environment, how do people normally do that? Because pretty much any company these days has an Active Directory on premises. It normally requires you to have a physical or a virtual machine on premises. This is a server. On that server, you or that company or technicians would need to go and add a role. The role you need to add is ADDS, which is short for Active Directory Domain Services. Once you've added that role, you have to go and promote the domain controller, choose your domain, and a whole lot of other things. It's not rocket science, definitely not. It can be done, guys, but what it is it's time consuming. Very time consuming and inconvenient is what it is. Now, if I were to go click here on this one in the cloud, the one you guys see here on the left, that says Azure Active Directory. If I were to go and click on that bad boy, check this out. Give it a moment, it's loading. All right, so right off the bat, I can go here to users or groups. And if you don't know what an Active Directory is, the one on premises is normally the one that installs your Active Directory software, which allows you to create your user accounts and your groups and stuff that you would have on premises. So when you log on in the morning, or users logs on in the morning, that is your Active Directory service, guys. That is where everybody's accounts are and where they authenticate to. This is not just in the cloud. But here in the cloud, right off the bat, I can click here where it says users. I can go and see users. I can go and create users. If I go back here, I can go to groups. I can go and see user groups. I can go and create groups right off the bat. The only thing you might need to still do is just link your company's unique domain name. And that's going to go very quick. Other than that, you can pretty much jump in immediately and immediately do all of this stuff. You did not need to go and create a server first, virtual or physical. You did not need to go and add a role or promote a domain controller or do this or do that or install server. None of that. So you're saving a tremendous amount of time. So in short, someone else, in this case it's Microsoft, has done most of the work for you, and you're just kind of jumping in at the last moment here, reaping the benefits. Pretty right. It's pretty sweet, right? There's a lot of things like that in real life at the moment, guys, and it's not just IT. Because a lot of us, not just in IT, are very busy these days, and we're also getting lazy, and we don't always want to do certain tasks anymore. And whenever people get very busy and there's certain things we absolutely need to do, that's normally a gap in the market. In this case, the gap was for Microsoft. Someone will see that gap and they will seize that moment and reap the benefits thereof. If I have to give you guys a random example, this is one I normally give to my students in a lot of the courses when I need to explain platform as a service. You can think of yourself as going into a grocery store. Imagine you had to go and buy vegetables, or imagine you had to go and grow your own vegetables in your garden. You know how long that would take for you to go and, basically pull the vegetables out of the ground or get them out of the ground, wash them, or go to the store, or to your local farmer's market or whatever. For you to go and do that, and then you still need to go home, wash the vegetables, slice them, dice them, peel them, and maybe cook them or freeze them. It's possible, it definitely is, and it's probably going to be very fresh. The drawback to that is it's very time consuming. Maybe 10 years or 20 years ago we could still do that, but these days everybody's living in a fast lane. We simply don't have the time. So now what? Someone saw a gap in the market and they said, hey, what if we went and did all of that for the customer and sold it as a solution? So now you can go into a supermarket these days and you can go to the freezers, wherever that might be in your local country. And if you go there, you'll find there's normally bags or something that's frozen. And these are frozen vegetables. It could just be peas, it could just be carrots, or it could be mixed vegetables. It's pre-sliced, diced, peeled, washed, frozen, everything. All you need to do is just throw it in your cart or your trolley. You go buy it, you go home, and you cook it. Maybe throw it in a pot of some water or however you plan on cooking it. So you're still going to do some work. Yes, don't get me wrong. You're still going to do some work, but it's minimal compared to what it could have been. It could have been a heck of a lot more. So someone there saw a gap in the market and they said, hey, let's sell this as a product. And Microsoft's basically doing the exact same thing here, guys, just digitally speaking. They know people don't want to and don't have the time to go and install server and add these roles and do all this stuff. So why not sell it as a solution? Thus the platform as a service. It's in the name. It says as a service. So they're selling you a platform as a service. Here we go. So now you know. And then the last one, guys, I can show you a really good example on Azure for that one. Software as a service is the one where you've got the least amount of control. So infrastructure, you've got the most, platform a little bit less, and software the least amount of control. So software is installed or running somewhere else, like Microsoft. I think Office 365 will probably be a very good example of that. And that software is now accessible to you and your users over the internet via something like a web browser, for example. So if you look at something like Office 365, you can run something like Word, Excel, PowerPoint, Microsoft Teams within a browser over the internet without installing it. So if it's not installed on your computer or the user's computer, it's not running on your computer or the user's computer, it's doing all of that somewhere else, it's just streaming it to you, the user, via the browser, via the internet. That, folks, is software now as a service. It's being rendered as a service to you or the user. Pretty dope, right? Anywho, let's go back to the presentation. Alright, so there we have it. I think we've pretty much more or less covered infrastructure, platform, and software as a service. I hope that makes more sense to you guys. So the last thingy-mabob I want to add here on this specific topic is cloud versus on-premises. So basically, in a nutshell, I'm going to be bragging to you guys about how good the cloud is. It's all sunshine and rainbows. That's actually what these cloud providers would like me to tell you guys. They would love for you to believe that everything in the cloud is sunshine and rainbows. And I suppose for the most part it probably is. But don't believe everything they tell you. It's only about 95% sunshine and rainbows. There are cases, and there's going to be times when something in the cloud is actually not so great. It actually is more expensive, or it actually is less reliable. But they will never tell you that because obviously it's bad for business. That is where I come into play, or wherever your trainer comes into play, whoever that might be. We're the only people that's going to be honest with you because I don't get anything out of this. I don't get paid for this. I don't get commission. I get nothing. The only thing I get here is if one of you guys go make a donation down below in one of those donation things I've mentioned normally at the end of the video. That's all I get. Other than this, I don't get anything for this. So cloud is generally better. It's more reliable because, obviously they've got two or more of everything. It is cheaper in most cases because they buy the hard drives and everything they need in bulk, so they can pass those benefits down to you guys now. So it's a heck of a lot cheaper. You don't have to go and buy any stuff. You don't have to go and build any stuff. It's always up and running. They give you a 99.9% uptime guarantee, for crying out loud. That equals to about 4 or 8 hours downtime per year, which is amazing. The benefits just keep stacking up, guys. If you had stuff on premises, like a server, you would have to go and buy that, build that, very, very expensive, and you're stuck with it now. And after 3 or 5 years, you've got to spend all that money again because your old service is now outdated. Sucks, right? Where in a cloud, you will always have the latest of the latest and the best of the best, and there's hardly ever any downtime. On premises, whenever you need to go and upgrade something or update something or fix something, it's downtime, 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 and the users are going to be on your neck about it. It's not cool. All right, so since we're talking about, the bells and the whistles of the cloud, that brings us to our last topic in the section, guys. Cloud characteristics. Oh, I hope I didn't butcher that name. I can't pronounce it properly, so if I butchered it, I apologize, but let me know in the comments down below. So I said cloud. The cloud, I'm pretty sure I'm saying correctly, but if I'm saying characteristics incorrectly, let me know in the comment section down below, guys. I'm very curious to know if I pronounced that correctly. Believe it or not, I'm actually not English at all, guys. I'm not. English is a second language for me. So if I've been doing pretty good at it, let me know. If I suck at my English, let me know. I'm curious to know. And if you are still watching at this point in the video, because this is the last topic in the last section of this video, because it's quite far, it's probably been more than an hour by now, drop me a random comment down below where you say cheeseburger. And if you say cheeseburger down below, it's obviously going to confuse the heck out of random people that's going to be reading the comment section, and they're going to see people typing cheeseburger, and they're going to have no idea what it's about unless they watch the video up until where you've watched it. So only people that's actually watched the whole video would know what the heck the cheeseburger is all about. So you can either go and type cheeseburger at the bottom, or you can make some sort of creative sentence in the comment section where you include the word cheeseburger. I'm curious to see what creativity you guys are going to come up with when it comes to cheeseburger. And obviously, yeah, let me know if I'm pronouncing that word characteristics correctly. So under cloud characteristics, I really hope I'm not butchering that. There's a lot of things I can tell you guys, but this is not a cloud course. So let's mention some of the most obvious ones. Metered utilization. I love this benefit, and I can agree with all the cloud providers. This really is something. You only pay for what you use. So if you look at something like on premises, where you have to go and buy a server or build a server, once you bought it or upgraded it, you are stuck with it, whether you use it or not. So if you've got a server that cost you millions, and now you find, okay, over the weekend you might not need it, you're going to go and turn it off, you're not saving money, because the only thing you might save is an electricity bill. But other than that, you still paid for that server. It's not saving you money, guys. But in the cloud, if you don't use something, you won't be paying for it. Remember, you only pay for what you use. So if I've got virtual servers running on as virtual machines, if I turn those virtual machines off, guess what? You're not paying for it. Huge benefits. You're going to save massive costs there for yourself and your company. The cloud gives you high availability, which I did kind of mention to you guys already. So they give you a 99.9% uptime guarantee. I don't have a calculator open right now, but if I do the math, that's about 4 to 8 hours. Sounds like a lot, guys, but really it's not. It's amazing. If you go and check how many times your servers are offline on premises, I can guarantee you it's going to add up to days, if not weeks. So 4 to 8 hours, it probably will be even less than that in real life, is amazing. And depending on what high availability options you choose, you can actually go and choose extra high availability options. You can actually get this to up to 99.95%, if not higher. The cloud also gives you scalability. It's not that we didn't have it on premises or don't have it on premises. We do. It's just very, very expensive and very, very time consuming. And once you've done it, you're normally stuck with it. So scalability can be two things, guys, on premises. You can either go and scale up or you can scale out. Scaling up is when you take an existing server, for example, and you upgrade it with something like more space, more RAM. That is scaling up. Scaling out is when you drop more servers, additional ones, clones, if you will. So I might have had one server, and if I just upgrade the RAM, that's scaling up. But if I've got one server and I drop a second server, which is a duplicate server, that is scaling out. Both of them can be done. Very, very expensive. Very time consuming, because normally when you want to go and upgrade a server, you probably don't have parts. You're going to have to go and buy them or order them. If you want another server, you might have to go and build it or order it once again. And that's going to take you forever and a day. And once you go and do either or, you are stuck with it, guys. And if you do need to go and upgrade a server, guess what? You can't do that in the middle of working hours, folks. You need to wait until after hours, or you need to wait until it's weekend, and then you can go and do it. So it's predicaments. Now in the cloud, you can go and upgrade a server or add more servers nearly instantaneously. I've seen, if I go to the Azure portal, which I showed you guys earlier, and I go to a virtual machine, I can go and change the specs of that virtual machine. I can, for example, increase the RAM in less than a minute. When in your life are you going to do that on premises? There's no way you can go and do that. Then the cloud also gives you rapid elasticity. Oh boy, that's another word I'm butchering. So if you guys, elasticity. I'm really going to try and say that slowly. Elasticity. Please let me know I'm saying that correctly. I'm really hoping, because I think I'm butchering it. At the very least, I butchered it the first time. So that means your resources will automatically and very quickly increase or decrease in the cloud as needed. So if you're hosting a website, for example, and Microsoft sees the resources you've allocated to that website is no longer enough, because maybe this is some spike in traffic, they can automatically increase your resources as needed. And if they see the demand goes down, they can automatically and instantly decrease it as needed to save you money. Same with your virtual machines. If you suddenly need more RAM or you need less, they can increase or decrease as needed. And if they decrease, obviously you're going to save money. The only concern some folks have here is, since we pay for what we use, and since Microsoft has the ability to go and increase, does that mean you could possibly receive a surprise in the mail where maybe one month there was a huge spike in traffic and Microsoft went and increased to the point where you can no longer afford it? Is that possible? Yes and no. You can actually go and specify a limit, a cap, if you will. And you can tell Microsoft, don't exceed this amount in monetary value, or do not exceed this amount in resource value. Pretty cool, right? The last thing I'm going to mention here for today, and then I don't want you guys to just disappear on me yet after I'm done on this topic, is shared resources. So everything you host in the cloud on entities like Microsoft is shared amongst other people. So if I host a virtual machine on Microsoft servers, it's actually on a server where other virtual machines reside from other companies. That might sound unsecure to you guys, but I can guarantee you it's not. Microsoft's got some of the biggest IT budgets and some of the smartest minds there, or whoever cloud provider you're talking about, and data leakage is not a concern. If you really, really, really are paranoid like my wife, if you've got enough money you are willing to throw at it, you can, of course, go and get yourself dedicated servers. Wow, I sound like I'm selling you guys something. I swear I am not selling you guys something. This really is just the benefits. It really is. All right, folks, that was the last topic in the last section. Don't disappear on me just yet, because I just want to thank the people that's been sponsoring the channel. So guys, if you haven't done it already, please give the video a like, subscribe, baby. And then a special shout out and thank you to all of those of you that's been sponsoring me and sponsoring the channel. The Patreon sponsors or supporters, the PayPal sponsors and supporters. Those of you that's been clicking on the thanks button below the video. Those of you that's been buying me a coffee or a milkshake. I appreciate all of you guys. So yeah, there's a list of the Patreons, there's a list of the PayPal supporters. Thank you very much, guys. And if you guys would like to sponsor me or the channel, you can find that information in the video description down below, right next to those awesome timestamps I've added for you guys. So in case you haven't seen it, in case you don't know about it, in every video description, I add a more or less list of the sections covered and a more or less list of the topics covered so that you can go and skip to certain sections if you want to go and revise or if you're looking for something specific, of course. Well, folks, that is me for this module. I will see you all in module 8 of CompTIA A+.